Hi guys, welcome to the notes for 4-13. Today we're going to look at solving trigonometric equations. So this is something you may have done in the past a little bit. Today we're going to just talk about some approaches that you can take for solving these equations without the calculator, and we will look at some with the calculator. All right, so let's start out first of all just by recalling some methods for solving different kinds of equations. You look at the first two that we have here. The first one, 2x squared minus 5 equals 1, right? It's a quadratic equation, and in this case, you notice here that we just have one x that's being squared. So usually when there aren't multiple x's or multiple variables, like for instance on the second one here, you see a t squared and a t, right? We're going to isolate that x to solve it. So first thing we would do, right, we would add our 5 and then we would divide by our 2. So we'd have 2x squared. When we add our 5, we've got 6. And then we divide by 2. We have our x squared is equal to 3. And then we would take our square root of each side. And this is the part that you have to remember to do, right? When we take our square root of something that's squared, right? We're thinking about the absolute value of x, right? Because the absolute value of x would equal the square root of 3, which then leads us to the whole, hey, x is going to equal positive or negative radical 3. Okay, so there is more than one value that we could plug in for x to make that a true statement. Both positive radical 3 and negative radical 3 will work. Okay, so two answers. And when we go to the second one here, we see we have 2t squared minus 3t minus 2 equals 0. Okay, when we're doing that one, right, this is just a quadratic, so we need to factor it. So I'm going to take this, I'm going to factor it into two binomials there, right? We know that this would have to be a 2t, this would have to be a t, and our only factors of 2 are 2 and 1, and we know that it won't be in the same binomial, or the two 2's won't be in the same binomial, so it's looking like we'd have a 2t and a 1 and a t and a 2, so we'll say, let's see, negative 2 times 2 is negative 4, plus 1 gives us that negative 3t, and then we would set each equal to 0, right? This is stuff that goes all the way back to Algebra 1. Okay, so we're going to end up here with t is going to equal negative 1/2, and t is going to equal positive 2. Okay, so again, two answers. So solving our trigonometric equations falls along the same lines. Okay, so the first one we're going to look at is 3 times the tangent of x squared minus 1 equals 0. So we're thinking about this one, we're going to solve it. Okay, so the first thing we're going to do here is we're going to look at its graph, okay? So I'm going to kind of show you on the calculator, when we're looking at the graph, what it looks like, and we're going to solve it over the domain from 0 to 2 pi. Okay, so let's look and see what we've got here. So I'm going to go ahead and, whoops, that's not my calculator. I think my calculator accidentally closed, so let me bring that back out here. I'll get that off of there. Hold on. Oh. There we go. All right, so when I do this, I'm going to think of this, right, as 3 times the tangent of x, right, when I do it squared, minus 1 in the calculator, and I'm actually going to make it equal to y in the calculator. So we'll go in here. First thing we're going to do, because we're going to be doing this in radians, right, our domains in radians, make sure you go into your calculator and that you have your calculator in radian mode. And then we'll go in here and we'll set our window. Okay, so our window goes from, well, our domain goes from 0 to 2 pi. So for my x-min, that's 0. When you type in 2 pi for the x max, right, you'll type it in like this, but as soon as you move it down there, it'll convert it to a decimal form. My scale, you'll see I have 1.57. All that is our value of pi over 2, okay, because I like to see it broken into quartiles. And then my y min, I'm going to make that negative 1. My y max is 1. And then I'm going to make my y scale a half. Okay, so I'm going to go into my y equals here. You see I have some things in there. I'm just going to clear those out. And I'm going to type in 3 times the tangent of x And then I'm going to close it. I got to square it afterward. Remember, that's how you type it in on the calculator. And then we've got minus 1. So when I graph this now, you'll see here that our solid orange line is the actual function. Okay, our dashed lines there would be asymptotes. Okay, so lines that it's not going to cross, or basically values where the graph won't work there. So you'll see here it crosses between 0 and 2 pi. It's going to cross once, it's going to cross twice, 3 times, 4 times. So it looks like we have 4 answers that we'll come up with. And you know what? Let's just go ahead and kind of jot those down. So for the first one there, right, we're looking at when y is 0, our x value is about 0.5235. So we'll just round it to the nearest thousandths place. We'll say x is going to equal 0.524. The second one, you'll see we have 2.618. The third one, it's like it is 665. And then the last one over here towards the very end would be 5.760. Okay, remember, these are all radian values, right? These are all radians. They're just not written in terms of pi right now. Okay, so when you think about your graph, and this is broken into 4 quartiles, so it looks like we have one answer in the kind of in that first quartile, the first quarter of it, right? We've got one right here. It looks like it'd be in the second one, the third one, and obviously the fourth quartile there. So we've got those 4 different answers. So when we think about it, okay, if we were going to try to calculate this by hand, right, we could still do that algebraically, and then we can kind of compare the answers that we see here, right? So we said that right now we're looking at there were 4 answers, and we have them listed below. So if we solve this by hand, let's see here, we've got 3 times the tangent of x squared minus 1 equals 0. So remember, solving trig equations, we want to make sure that we're isolating the trig word. So like right now, we're going to try to isolate the tangent of x squared, right? So we're just adding 1 and then dividing by 3. So we have the tangent of x squared is going to equal a positive 1/3. And then when we take the square root to undo the fact that that's being squared, right, it's still going to have the tangent of x in absolute values like you did in that warm-up problem on the first slide, right? And that's going to equal our square root of 1/3. Now we know the square root of 1 is simply 1, so we can say this is 1 over the square root of 3. And then, that's going to lead us into getting the tangent of x should equal, and if we rationalize our denominator, this might look a little bit more familiar. So we'd have a positive or a negative when we take it out of the absolute values, and then it looks like we're going to get the square root of 3 over 3, which is the fraction that hopefully looks a little bit more familiar to you. So then we'd have to come up with what our answers are, right? So we're saying what angle measure, right? This is referring to what angle measure are we going to have where the tangent values are positive radical 3 over 3 and negative radical 3 over 3. So a couple ways you can kind of come up with this. Let's first draw out just our 1, 2, 3, 3, 2, 1 chart if you're one of the people that likes to use this one more than the actual unit circle, right? So when we think about it, when you're looking at that chart, where is the radical 3 over 3? Well, it's down here, right, in this bottom corner, which means our reference angle is pi over 6, right? So when we're down here, we're thinking about our reference angles of pi over 6. So we can take it and we can also look at our unit circle, right? Let's just put that out here, put in our x and y axes, okay? So when we think about our unit circle and where our angles are with reference angles of pi over 6, well, in the first quadrant, right, that one's easy. That is pi over 6. In the second quadrant, we are at 5 pi over 6. In the third quadrant, or down here, we're looking at 7 pi over 6. And then in our fourth quadrant here, we're looking at our answer would be 11 pi over 6. Okay, now, these answers that we get right here, right, these are our answers. We've got x equals, we'll just say pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. Okay, so those are the answers, but they look way different than these answers, right? But just remember, you can take any of our answers from the very bottom. Let's just take like our pi over 6, for example, right? And if you go into your calculator and we do pi divided by 6, right, you'll see that our answer is 0.523, right, which is, just the rounded, or, similar to our rounded version of 0.524, right? So these are just in decimal form right here because the calculator is not going to spit it out in, in terms of pi. It's going to give us the decimal approximations for each of those. Okay, so that's how you see that you get the same answers. Okay, so let's move on to the next one. It says solve each equation over the interval from 0 to 2 pi. So we're still looking in that, one time around the unit circle. We have the sine of x plus the square root of 2 equals negative sine x. All right, so if I'm trying to solve this, right, I need to have all my x's on the same side. So let's just go ahead and add a sine of x to each side. But since we already have a sine of x here, right, now we've got 2 sine of x's plus the square root of 2, and now that equals 0. All right, and so remember, when we're solving these, we're trying to isolate the trig word. So we're trying to isolate that sine of x. So we're going to subtract the 2, or the square root of 2. And then we're going to divide by the 2 that's in front of the sign. And we've got that the sine of x is equal to negative radical 2 over 2. Okay, so again, we're looking for our answer in radians because that's what our interval is set up as up there. Okay, so we need to figure out, where we're going to be. Let's think about that. You can use your 1, 2, 3, 3, 2, 1 chart, or you can take it and, just visualize, or, some of you, may need to draw it out here. That's no problem. So where is our sine going to equal negative radical 2 over 2? Well, our y coordinate would have to be negative radical 2 over 2 down here, right, in the bottom. Okay, it's about halfway. So when we look at that there, right, that's like our pi over 4 angles that are down here, right, because these ones have those coordinates of negative radical 2 over 2 for the y's. Right, this one's negative, oops, it doesn't, well, it's negative radical 2 over 2, negative radical 2 over 2. I was just trying to show it for the y. Okay, so we know that, this one's pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. So down here we know that this is 5 pi over 4. And over on this side, this was 6, so we were at 7 pi over 4. So our x would equal 5 pi over 4 and 7 pi over 4. Okay, so if you have any questions about that, please go ahead and, mark those down. So real quick here, if we're talking about checking it, so let's see here. If I just took one of my angles, let's say 5 pi over 4, I'm going to check it with that one. So I'm going to say the sine of 5 pi over 4 plus radical 2 should equal negative sine of 5 pi over 4. Let's see what we get, right? So the sine of 5 pi over 4 we know should be negative radical 2 over 2. Then we have plus radical 2. Okay, so if we're trying to come up with what that would be, we need a common denominator. Let's multiply, right, top and bottom by 2. So I have a negative radical 2 over 2 plus 2 radical 2 over 2, which is going to get me just radical 2 over 2. And then we look at this side here, right? So that turns it kind of into a positive there. Let's look at this one. So if I do on the right side, our sine of 5 pi over 4 was a radical 2 over 2, and it's negative, right, because it's down on the bottom. And then when we do the opposite of the negative there, we also get that this one is equal to radical 2 over 2. So, right, so they're equal to each other. So don't be afraid to check your answers. That's kind of fun. All right, let's move on. So the next one, 2 times the sine of x squared minus the sine of x equals 1. Okay, so some of you, if there's lots of signs and things going on here, you could always do something like this. We could say, hey, let's just let u equal the sine of x, right? So we could substitute in a u anywhere we see a sine of x. So it's like 2. Since this is like the sine of x squared, right, then we could treat this as 2u squared minus another u is equal to 1. And when you look at it there, really it's just another quadratic. So we'll set that equal to 0. 2u squared minus u minus 1 is equal to 0. We'll factor that. Right, so we've got 2u, we have a u. We know these have to be 1, and since we need more negatives and positives, we need negative 2 plus 1. So we've got 2u plus 1 equals 0, u minus 1 equals 0. So u is going to equal negative 1/2, and u is going to equal 1. Okay, well now let's just take it and put our sine of x back in. We have the sine of x equals negative 1/2, and we have the sine of x is equal to 1. And now we can look at figuring out what our angles are that need to make these true, right? So we're still in that interval from 0 to 2 pi. So when you think about your unit circle, right, where's the sine 1/2? Ooh, I missed on that one, didn't I? We'll just move that over a little bit. Thanks. All right, so the sine is 1/2 down here, sorry, negative 1/2 down here and down here, which we know are pi over 6 angles. Right, so this one we know is 7 pi over 6. This one is 11 pi over 6. And then where's the sine going to be 1? Well, this is the only point up here that has a y-coordinate of 1. So we know that we would also have a pi over 2. So our answers for this, right, x on this one is going to be 7 pi over 6 and 11 pi over 6. And on this one, x is going to equal pi over 2. So there's 3 answers on that one. Okay, and if you wanted to check it, you could take it just to double check that you had all the answers that you needed. Right, let's take this and let's do 2 times the sine of x, and then we're squaring that. We'll subtract the sine of x. And then I'm going to subtract 1 and set it equal to 0 so I can count the number of x-intercepts that I'm going to have. So let's graph it. And you'll see that it looks like it bounces right there. So there's one answer, right? That's our 1.57, so that's our pi over 2. Here we have that 3.66 there. That's going to be our 7 pi over 6. And over here is our 11 pi over 6. So 3 answers, what we're looking at right there. All right, moving on. Solve another one. So just looking at different types of equations that you'll see. If you look at this one here, wow, we've got 2 different trig words happening. So the sine of theta times the cosine of theta minus 1/2 times the cosine of theta. Right, if we were trying to solve an equation normally, right, we've got basically 2 terms, right? We've got sine of theta times the cosine of theta, and then we have that 1/2 times the cosine of theta. Since there's multiplication in both, do we have a common factor? Right, we have a cosine of theta in each of them there, so let's factor out that common factor. So we have the cosine of theta, and when we take that out, what's left over? Well, the stuff that we didn't highlight is left over. The sine of theta minus 1/2 equals 0. And now we'll choose our zero product property. We'll say that either the cosine of theta equals 0 or the sine of theta minus 1/2 equals 0. So we'll just solve that and then identify our answers. So cosine of theta equals 0, right? Remember, we are over here. Let's see, on the y-axis, right? So we have one there, because this is that point 0 comma something. This is 0 comma something, so we're down here as well. So theta, in this case, is going to equal pi over 2 and 3 pi over 2. And on the other side here, we're looking at where the sine is 1/2. That's going to be our lower angles in the first and the second quadrants. So we're going to say answers there. Theta would be, looks like, what is that, pi over 6 and 5 pi over 6. And there we go. So there's 4 answers on that one. If you're having questions, please make sure you're marking them down or reaching out to me. All right, so another one here. Sine squared theta minus sine of theta plus 1 equals cosine squared theta. So when you think about this one, right, we've got a trinomial here. Okay, this one we have a cosine squared. So like if I subtract that across, right, that's not really going to do much for us because we can't really factor one of the trig words out. So what we'll end up doing here is let's take this and let's turn it into sine and then combine all of our sines together. We know that the cosine of theta squared, right, should equal 1 minus sine squared theta there because that is our Pythagorean identity. So let's just replace that with 1 minus sine squared theta. Right now that equals the sine of theta squared minus the sine of theta plus 1. And now we're just going to set it equal to 0. We'll subtract 1 from each side. We'll add a sine squared theta to each side. And that was very not straight across. That's a little better. So we now have 2 sine squared theta minus the sine of theta, right? This is a 0 pair, so that's canceling out. And we know that both of those canceled out. So this should just equal 0. And now we can just take it, we can factor out a sine of theta. And we've got 2 times the sine of theta minus 1 left over. And the rest is just algebra, right? So set that equal to 0. Set this one equal to 0. And solve them. So our theta here, where is the sine going to equal 0? What angle has a y value of 0? And again, if you need to draw it out, that's fine. Go ahead and do that. Right, where's the sine? Where are the y coordinates 0? Well, the y coordinates are 0 here and here. So if our interval goes from 0 to 2 pi, and I think we're excluding 2 pi, we're going to say that we'd have 0 radians and we would have pi radians. And then on the other side here, I think we just did the same one, right? 1/2. So we know that theta in this case is going to end up being pi over 6 and 5 pi over 6 again. So again, 4 answers. Questions? Mark them down, send them to me. I'm here to help. All right, let's move on. Last one says, find the solutions to the equation using a graphing utility. That means a graphing calculator of some sort. It says, give answers in degrees rounded to the nearest tenth. Okay, so they give us, they tell us they want our answer in degrees. So, I mean, we're thinking about our interval then should be from 0 to 360 degrees, not pi, not 2 pi on this one, because it already told us we're doing degrees. So let's take a second here and look at our equation. 2 times the sine of 3t plus 1 equals a negative cosine of t over 2. Okay, so when I take this, I'm going to type this in the graphing calculator. You can do it different ways, but I'm going to take it and set it equal to 0 so I can just count my x-intercepts. Okay, so I'm going to set it equal to 0. And when I do it, I'm going to change it to x's just so I'm typing in the same thing that I see on my paper. So I'm going to just deal, instead of t, I'm going to do x. So 2 times the sine of 3x plus 1. And then I'm going to add this over to the other side. So plus the cosine of, I'm going to say x over 2 equals 0. And now we're going to take it and we are going to get out our calculator. First thing, remember to put it into degree mode. Okay, so mine is now in degrees. I'm going to make sure my window is still set up. Yep, mine still goes from 0 to 2 pi. And then I have it broken into increments of pi over 2 for my x's, and then negative 1 to 1. Okay, so right now that's what it is, right? But if we're doing this in degrees, what do we need to do? Well, this needs to be changed to 360, right? Because 2 pi is 360. My increment I had was pi over 2. Now I just want that in 90-degree increments. And for my outputs there, they are going to remain as negative 1, 1, and 1/2. Okay, so that's what your window should look like. And then we'll go in here, we will clear out the top, and we're going to type in our new function. 2 times the sine of 3x plus 1. And then we're going to add the cosine of x divided by 2, close it, and then we are going to graph it. So it looks like in this case, we're going to have 1, 2, 3, 4, if it'll respond, come on, respond, 4, and then 5 answers. Okay, so we'll just jot them down. The first one, it said round to the nearest tenth, right? So we're going to say x is going to equal 67.8 degrees. Next one, 114.4 degrees. Next one, 179.7 degrees. We have 244.9 degrees. And then our last one there. Come on. There we go. 291.5 degrees. Okay, so you see we actually have 5 answers on that one. But we just used our graphing calculator to come up with them there. Okay. You should know how to change it from degrees to radians, radians to degrees, and how to find x-intercepts by this point. If you forgot, look it up online. It's not hard to do. Type it in on Google, and it'll pop up with probably 1,000 different YouTube videos showing you how to do it on whatever calculator that you need to do it on. All right, otherwise ask me for help. That's it. Thanks for watching.